make sure to like and subscribe right now. Yes, do it. This is Ron from MathX, and today we're going to be solving the number 25 from the AMC of 2017. But also, we're going to have a brief update on this channel that we've been working on for so long. You may have heard this. MathX is the channel you're watching right now. But we're going to be telling you a bit of an update on it. But anyways, without further ado, let's get started. So, you may be wondering, what is this so-called update on channel? Now, we've been working on this channel for like 2 years, and I came to realize that we don't really have a decent upload schedule. And they have very big time gaps and sometimes very short time gaps. So, to keep a concise and close upload schedule, we've decided that we're going to be uploading every Friday or Saturday. So if you guys come to watch a MathX video on Friday and you get disappointed on there, well, you'll know that you're going to get a video just a day after. A bit delayed because it takes time to make these videos. We put our heart and soul into making these. So also that leads us to just for me to say, please, for the love of God, like and subscribe right now. But I'm going to be upfront. Just subscribe. Just check the subscribe button. Make sure to like, comment. Just please. But anyways, instead of me here begging for you to watch my videos, how about instead we go into doing a math problem? And this math problem, it's going to be a surprise. Now, you best have been focusing, because if you were, you would know what the problem is. And I know you're going to rewind, but you can still do it. I'm fine with it. Just watch more videos. I'm going to stop begging. But anyways, today we're going to be solving the number 25 from the 27 AMC. Now, this is the problem here. And in this problem, it may seem very difficult to you because this shape is so weird. It looks like an equilateral triangle in between, like, I don't know, it looks similar to like a cone. And I don't like the weirdness of the shape. So, anyways, let's get into the problem and we'll fix this weird shape because it's scaring me. But anyways, in the figure shown, US and UT are line segments, each of the line with length 2. M angle TUS is equal to 60 degrees. Arcs TR and SR are each 1/6 of the circle with radius 2. What does the area of the region show? Okay, so the area is clues in the problem. It says arcs TR and SR each 1/6 of a circle with radius 2. So these arcs here, we can make a triangle, like a huge triangle here. And these are going to be 1/6 of a circle, which can combine to make 1/3 of a circle. But anyways, I want to get this ugly diagram on my face. So we get this triangle. Now, this is the complete diagram of what they would mention in the problem, except we added a bit of touches because they never mentioned the center points of the circles. So we decided to make variables for them called x and y. And x and y are going to be having these radius 2 of the circles connecting to the US and the UT. So now the diagram's a lot less ugly and we can do a lot more stuff with it. So essentially, first thing we can notice here is that UXY is an equilateral triangle. We know it, and you may be wondering, oh, how do you know it? Basically, for this angle, I guess, is going to be the TUS. They said in the problem 60 degrees. And because this is each 1/6 of a circle, and a circle has 360 degrees, we can divide 6 to get the 1/6. So we know that the SXR is going to be that 60 degrees. So now that we've confirmed that this is going to be an equilateral triangle. Let's label that out so we remember this. Next thing we can also label is that the TUS, the SXR, and the TYR are all equal to 60 degrees, as is the equilateral triangle. Now, the next thing we can do is find the area of this equilateral triangle. Now, you may be wondering, oh, I don't want to find the area of an equilateral triangle because it takes more time. Well, that's why we have a neat trick in hand. We have a formula for the area of an equilateral triangle. Now, you want to see what it is? Is it drum roll, please? We have this. Now, you may be wondering, what do we do with this formula? Like, what does the A represent, for example? Well, in this case, the A will represent the side length of this equilateral triangle. Now, let's test this formula out real quick on this triangle. Now, we know that the side length of this triangle here is going to be 4. So, we plug that in. 16 root 3 over 4 is just going to be 4 root 3. Now, instead of using this formula, let's test another way. Let's use just half base times height. So we'll have to calculate the height of this, and I don't like to do that. So I'll have to do it anyways. But for this, we're going to calculate the height by using Pythagorean theorem. Now, we just have to find ux squared minus xr squared. And ux squared is going to be 16, and xr is going to be 2. So 2 squared, 4. Then 16 minus 4 is going to be 12. Then we have to find the square root of 12, which is just going to be 2 root 3. Now, half base times height, and xr is going to be 2, and it's half the base. So 2 times 2 root 3 is just going to be 4 root 3. Now, tell me, what was easier, using the formula or doing all that work out? For me, I think it was using the formula. And you should too, because it's much easier, and you can calculate the area much easier. But anyways, we've gotten the area of this triangle. It's going to be 4 root 3. So now that we've gotten the area of this triangle here, next thing we can do here is get the area of these small circles. But let's keep out this formula and our area because we're going to be subtracting these circles from it. So here we have it, 4 root 3. Next thing we can do. So it tells us in the problem that each of these circle segments are going to be 1/6. Now, since there are 2 of them, there's going to be 1/3 of the circle. Now, we know a neat little formula for calculating the area of a circle. Pi r squared. You may not have heard of it, but now you do. So pi r squared is essentially having the radius of the circle, plugging it in, you'll get the area of the circle. That's why it's pi r squared. You multiply by pi. Now, since it says the radius of the circle is going to be 2 pi r squared, you're going to get 4 pi. Now, you have to divide it by 3 since you have to find the 1/3 of the circle. So 4 pi over 3 is what's it going to be. And that's precisely what it's going to be here. Now, next thing we do is the final step. It's very simple. Now, very much legendary technique used throughout all of mathematics. It's subtracting. 4 root 3 minus 4 pi over 3. That's just going to be our answer in this case. So we have our answer here as B. Okay, as you can see, we have solved this problem, meaning we are now officially finished.